talk about layer 7 load balancer. This is actually fancier. But let's consider this. Okay, this is a layer 7 load balancer. What it actually means is it operates at the layer 7. That means it can see the application data. It is authorized to see that stuff. It is authorized to decrypt. If you told it to, okay, it's gonna establish a TLS connection between you and the client. What does that mean? Between the client and this load balancer, gives you the certificate of the load balancer, and it can decrypt your stuff. Okay, it can look at your stuff and it can make decision. If it's HTTP, it can just look through that stuff. Okay, and then what happens is it will make decision based on that. So what I'm gonna do here is I have this microservices example here where I have an IP address here, service dedicated just for serving pictures, voice notes on WhatsApp, pictures on WhatsApp or Instagram, wherever, right? I have a dedicated server. It has a higher bandwidth, maybe. It has, I don't know, more processor power, has compression, has caching, all that kind of stuff. And this guy, maybe this is hosted on S3. This guy, just for comments, stores numbers and the strings, which is the comments. Maybe we're using MongoDB or a Postgres database here, okay? But the client talks to one server, the one load balancer, okay? I don't know if we're gonna call this load balancer here, but it's actually more like a reverse proxy ingress. But it's the same concept, right? You can still load balance things based on the picture here. So what I'm gonna do, the client will make a TCP connection between itself and the load balancer, and then what the essentially says, okay, I'm coming from me, going to you, sir. I want to get pictures. Give me all the pictures, and it doesn't obviously exist here, right? This get request. So now it will actually look at the data and say, oh, and there's a rule says, okay, if/pictures, then forward to this set of nodes. And it could be one machine, could be 7 machines, all right, guys? And then it could pick load balancer between these machines. And it says, okay, wait a minute. Okay, you want to go there? I'm going to stop you there. This is me and you. This is one TCP connection. I'm going to establish a connection between myself and the server that you want to communicate to. So it's going to create a new TCP packet, forward that stuff to that server 44333 and coming from that. So again, the server doesn't know which client is coming from. It might even change the headers. It might actually add more headers. It might just modify the content because it owns it, because it can look at it, because it has full access to all that content, if obviously it can decrypt it, okay, which it can. And so what you see here is actually 2 TCP connections, okay? This could be secured TLS, right? So the TLS handshake should be happening here. And if you decided to have TLS at the back end, which you should in case of a cloud application. Some of you guys noted that in my previous video. Yes, I said that you don't have to encrypt at the back end, but it's a good idea to encrypt it. Obviously, you're adding the overhead of encrypting and decrypting, but essentially that boop, 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 that's 2 connections, okay? And then you get a picture, you're gonna forward to the picture. So what happens if I want to go to the comments? Well, it looks at the rules, find the rules that you're going to comment, establishes a connection with the guy, 4444 from 2, and then just forward the connections, right? Gets the response, get back the results, and then forward it back to the client. So it maintains 2 connections and takes the data, re-encrypted with the new TLS certificate, and then pass it in, not necessarily, the symmetric key, and then pass it to the client. So it does decryption, encryption, decryption, encryption. It does a lot of stuff, but it gives you huge benefits, okay? Let's talk about pros and cons, guys. Pros and cons. Pros, what's good about this? Well, smart load balancing. We can do a lot of smart load balancing. We can do all this microservices stuff. We can look at the data and make decisions based on the data and forward the data based on certain logic, right? On the headers, which is pretty powerful if you ask me. It can do caching! Yes, it can do the caching. because now I know you are requesting /index.html. I know that I keep this stuff cached, handy dandy on my machine. I'm gonna serve it to you because I look at the data. I look. And then it's great for microservices as we showed. And cons. What's the bad thing about this? Is there something bad about this? Well, it is expensive. It looks at the data. Again, guys, you can argue with me. A lot of people say, even in Nginx and their website say, yes, it's more expensive, but it is almost insignificant because our machines are very powerful stuff, and just doing extra encryption or decryption is nothing to it, right? And looking at the data, right, parsing the data, that's not much. Okay, it's maybe a few cycles more, but nevertheless, it is more expensive. If you're using a Raspberry Pi as a layer 4 load balancer versus layer 7, you can see the difference. It decrypts, as we said, it terminates TLS if it has one. It decrypts the data, so it sends the client back the certificate of the load balancer. So it might use a server name indication here to serve different connections, right? Different certificates, right? Especially if you're having multiple domains going through that, right? Because users can actually like go to about.example.com or example.com or www.example.com. If you have multiple domains, you can go to the same IP but serve different certificates. You can do it here because you are essentially the terminator. You terminate TLS. It has 2 TCP connections. Okay. Pros and cons, obviously, it's less secure, in my opinion, again, because it just looks through your stuff, and maybe you're not comfortable that the load balancer looks at your data. Some people don't, right? Right. Some people are paranoid that, hey, I don't want the load balancer to look at my data. I want it to be a dumb layer 4 load balancer. Okay. 2 TCP connections, obviously. So which means more, which it could be a good thing or a bad thing, in my opinion, right? A bad thing because more connections, you have to believe it persisted, right? That means these timeouts are very critical, right? Especially if you're using layer 4 load balancer versus one timeout. But with these TCP connections, you can use, I don't know if layer 7 load balancer like Nginx or haproxy does that, but I would imagine sharing different clients with the same TCP connection at the backend, because they don't care as long as you can send data through the same connection. Why do you care, right? So I would pool these connections. If I would implement this, I would pool these TCP connections, and if I would serve by 100 clients, I could use 3 connections to serve at the back end to serve all these 100 clients, right? But I might be wrong. Okay, I never implemented a proxy before, so I might be wrong, right? Again, guys, correct me if I'm wrong, if I'm saying BS stuff. Must share the TLS certificate. We talked about that. If you don't trust the load balancer, you don't have choice. You have to share that certificate. All right.